Lauren, what's wrong?
I can't figure out this math problem. Calculus is so hard.
It's okay, Lauren. I, Bill Nye, will help you.
Thanks, Bill Nye.
So here's our problem. Major League Baseball has determined that the average price of a ticket to a game can be determined using the formula P of T equals 0.03 T squared plus 0.56 T plus 8.63, where T is the number of years since 1991 and P of T is the price of the ticket in dollars.
The question asks us to use the definition of derivative as a difference quotient to find the instantaneous rate of change of P at the year T. I'm going to repeat it. The question asks us to use the derivative. Hold on. I can't read. Okay. The question asks us to use the definition of the derivative as a difference quotient to find the instantaneous rate of change of P at the year T, and it specifies that no shortcuts are allowed. And the equation that we want to use for that is f of x plus h minus f of x all over h. And basically what this means is, because P of T is f of x, that every t you find here, you're going to replace with x plus h. So you'll have 0.03 t plus h squared plus 0.56 t plus h plus 8.63.
Exactly. And then, as we move to the second side of the equation, the minus f of x, you're going to take the whole equation again, and then you're going to put it in parentheses and add a negative sign in front. So remember that this has to apply to the rest of the equation. And then you're going to divide it all by h.
Here, what my associate Bill Nye has written is that exactly what we just described. This is the derivative of the function. I know it looks really long, but if we take it piece by piece, it'll look simple. One thing that you have to always remember is that this negative sign here is to be distributed to each one of these, meaning that they're all actually negative. We can just remove those. Now what we need to do is simplify these by distributing this number into here and this number into here. Keep in mind that in this situation, we decided to replace the t's with x's to make it a little bit simpler for us to understand what it means.
Now we'll be completely expanding the problem. So right here, we have an x plus h squared, as written right here. So we got to remember to distribute everything in to make it an easier problem to solve. So that will leave us with an x squared plus xh plus xh plus h squared. And that's still in parentheses with the 0.03 out in front.
Okay, now that we've reached this point, we can see that we have two like terms, x plus h and x plus h. So we can go ahead and simplify that to 2xh. Now we're going to finally distribute in the 0.03 into this whole thing, which will give us 0.03 x squared plus 0.06 xh, because we have to multiply by 2, plus 0.03 h squared.
And then you'll just continue on with your equation by distributing everything that needs to be distributed in.
Okay, what we've done here is we've simplified the rest of this by distributing the 0.03 and the 0.56 into what we had in parentheses. So now our very long equation is 0.03 x squared plus 0.06 xh plus 0.03 h squared plus 0.56 x plus 0.56 h plus 8.63 minus 0.03 x squared minus 0.56 x and minus 8.63 all over h.
And now, here's the easy part. We get to cancel a lot of this stuff out. So as you can see, the 0.03 x squared crosses out with the negative 0.03 x squared. Let's see what's next. Our 0.56 cancels out with the negative 0.56x. Our 8.63 cancels out with this negative 8.63. And that's all.
And now we can write out what we're left with. It is 0.06 xh plus 0.03 h squared plus 0.56h, all over h. And one thing we kind of forgot to mention to you guys earlier was that this is a limit problem, so we need to write in limit notation by saying the limit as h approaches 0 in the front of the equation.
So now we can cancel out some of our h's because we have h's in the denominator and in the numerator. So we'll take this one, which will cancel this one, and one of these h's and this one, leaving us with, we still have our limit, so we have to write this in front of our problem. Limit as h approaches 0 is 0.06x plus 0.03h plus 0.56.
Now, the final step is that we have to remember that h is approaching 0. Therefore, if we plug 0 in for h, anything that has an h is automatically canceled, leaving us with a final answer of 0.06x plus 0.56. And that is how you use the difference quotient to find the instantaneous rate of change without using any shortcuts. And that is how you solve part A of question 1.
As Bill Nye Part 2 starts writing up for question 1 Part B, you can check your answer in Part A using Desmos or taking the derivative the easy way.
The derivative the easy way, we multiply the exponent down in front of your variable, and so for this it'd be 0.06t because you also drop an exponent as you do that. And we'll do the same for this one, and we'll imagine that there's an imaginary 1 right here, and so that would be 0.56, and then dropping the exponent would lead us to losing our t, and this stays like that, and then 8.63 is just eliminated because it doesn't have a variable. And this is how you check your answer.
Now on to part 2. The question asks us to use calculus to determine p prime of 30 and explain in a sentence what we found. So p prime of 30 is basically taking the derivative that we just found, which is p prime of t, and replacing t with the number 30. So simply, we just add that to the equation. It's 0.06 times 30 plus 0.56. Go ahead and input that into your calculators or into Desmos, and you will find that the answer is 2.36, or because this is a money problem, $2.36.
So how do we put this in a sentence?
Well, we can think about what the context of the question is. It is saying that t is the number of years since 1991. So 30 is 30 years since 1991, or 2021. So to explain this in a sentence, what it means is that in 2021, just the year 2021, the price of the ticket increased by $2.36 because the instantaneous rate of change only applies to the year given. $2.36 in the year 2021.
And that is the answer to question B. Now let's move to C.
So let's read the question. It says to compare the average rate of price change from 2011 to 2021 and compare that answer to your work in Part B. So we have to think this is not our instantaneous rate of change anymore. So we have to use the average rate of change equation, which is f of b minus f of a all over b minus a.
And now it's time to plug in some values.
And to think about it, it specifies 2011 to 2021, meaning that our A value is 2011 and our B value is 2021. We already know that 2021 is 30 years after 1991, so our B value is going to be 30. And our A value being 2011 will be 10 years less than that, so it will be 20.
So let's plug in these values. So we'll have f of 30 minus f of 20 all over 30 minus 20. Now let's see what these give you. So we already know that our denominator will be 10, and Bill and I too will explain the top.
So simply what this is saying is that, like we did before, we need to plug 30 in to the numerator. So I'll just write this in as f of 30. Because it's simple, you can plug it into Desmos or into a calculator, and then f of 20 is going to be doing the same thing. You're going to take the original equation and you're going to plug 20 in for every t value. You go ahead and plug that into your calculator or into Desmos, and you will find that the answer to this equation is $2.06.
And now we have to compare this to our answer in part B. So what is the difference between your instantaneous rate of change and your average rate of change?
So the instantaneous rate of change is what the rate of change is in just 1 year, while the average rate of change is the rate of change over time. So we can conclude that if the average is $2.06 and in 2021 it raised by $2.36, that in 2021 the price of tickets was 30 cents above the average. And that's how you explain part C in a sentence.
And that is all your answers to the question 1 of our calculus final.
Thanks, Bill Nye.
You really are a smart cookie.
Bill Nye the Science Guy.